Assalamu alaikum student. Today our topic is current electricity. SLO of this topic is solve word problems related to simple series and parallel combinations of resistors. So we are going to do numerical problems of this topic. Before doing the numerical, uh, we are sharing these symbols of electrical components. You see, the first symbol is of cell, then battery. You see two lines of cell, one smaller, one bigger. This is negative terminal, this is positive terminal. This line connected to positive terminal of the cell, and this line is connected to the negative terminal of the cell. Second is battery. Battery consists of more than one cell. Then DC power supply. This is the symbol of the DC power supply. Third is AC power supply. Power supply, you see the symbol of AC power supply. The difference between both the symbols is this line, this wave type line. Then voltmeter, V is written in voltmeter, ammeter, A is written in ammeter. There is P written in ammeter, so it is also correct, and generally we are using AMMETER, ammeter. M is used for motor, G is used for generator, and then this symbol is for filament lamp, bulb, normal bulb. This is the symbol of the diode, LEDs, LDR, fixed resistor, variable resistor, fuse, thermistor, heater, loudspeaker, switch open. Switch open means switch is off. Circuit is broken. Switch closed. Switch closed means switch is on. Electron is or charges is flowing. Okay. There is one more symbol of fixed resistor, that is like tooth edges. Okay. We will use this symbol also in our numerical. Both the symbols are used in the numerical problem. In the previous lesson, we have drive the formula for resistors are connected in series, and the equivalent resistance are connected in parallel. So, we also have done Ohm's law. So, we are going to use these formulae in our word problems. These are the formulae. In series circuit, you see the formula RE is equals to R1 plus R2, V is equals to IR, I is equals to I1 is equals to I2 is equals to I3, or V is equals to VI plus V2, V1 plus V2 plus V3. In parallel circuit, 1 upon RE, equivalent resistance or effective resistance, is equals to 1 upon R1 plus 1 upon R2 plus 1 upon R3. V is equals to IR, 1 I is equals to I1 plus I2 plus I3. Here, by mistake, plus is written, it is equals to sign. Now it is V is equals to V1 is equals to V2 is equals to V3. We are going to use these characteristics and formula in our numerical problem. Example number 1. In the given figure, three resistors are connected in series. Find the following quantities. You see these three resistors. I told you there is one more symbol of resistor. This is the toothed edges, right? In the previous, this one is also the symbol of the fixed resistor. So both are the symbols of the resistor, and this is also, here we are using this symbol. R1, the resistance of R1 is 100 ohm. The resistance of R2 is 300 ohm. The resistance of R3 is 50 ohm. Part A, equivalent resistance of the series combination that is required. Second, the current flowing through each of the resistance. That means what is the current across R1, across R2, or across R3. Number three, potential difference across each of the resistance. What is the potential difference of R1, R2, and R3? We have to find all these three parts. The first we are uh, going to do find the equivalent resistance. Data, we extract the data from the figure. R1 is given 100 ohm, R2 is given 300 ohm, R3 is given 50 ohm, or voltage is given 9 volt. The battery we are using is 9 volt. According to the formula, R is equals to R1 plus R2 plus R3, because resistors are connected in series. So we are going to use this formula, 100 plus 300 plus 50. So total resistance of the resistor is the 450 ohm. You see, the total output is greater than, that means the resistance is greater than in series combination, that is 450. Now, as we already have learned that in the series combination, the current is same as the battery. Okay, whatever current is in the battery is equals to the current of the resistor. R1 is equals to R2 is equals to I3, R3. Okay, all the current are equal to the current of the battery. So according to the Ohm's law, V is equals to IR, or I is equals to V upon R. Here we are using total voltage of the battery and total, or if equivalent, the resistance of the resistors, not R1, R2, R3, because we have to find the current of the battery, because all the currents are same in the series combination. So just find out the one current, that is the current of the battery. So in this case, use total resistance also. So V is 9 volt as given, and the total resistance is 450. We have already find over here. So 9 divided by 450, that means 0.02 ampere. Ampere is the unit of the current. In the previous classes, we have learned about it. So I is the current, I is current, and 0.02 ampere current is flowing in this circuit. Now, potential difference across each resistor. In a series circuit, potential difference across each resistor is different, but the sum of all the potential differences V1 plus V2 plus V3 is equals to the voltage of the battery. That means if you are using 9 volt battery, then sum of all these resistance potential difference is equals to 9 volt. So to find this, we have to V1 is equals to IR1. I is 0.02, R1 is 100. So it is 2 volt. That means potential difference of R1 is V1, that is 2 volt. Potential difference of R2 is V2, that is 0.02 multiplied by R2 is 300 is equals to 3 volt. The potential difference of R3 is V3, and that is 0.02 multiplied by 50 is equals to 1 volt. So if you want to verify your answer, add all these three voltage potential differences: 2 plus 3, 6 or 7, 2, 3, 5 or 6. All right. So add all these three. It is equals to 9 volt. It is 6. It is not 6. It is not 3 volt. It is 6 volt. 300 multiplied by 0.02, it is 6 volt. So 6, 7, 8 or 1, 9. It is 9 volt. Okay, do correction. Here is 6. All right. Next example is 2. In the given figure, three resistors are connected in parallel. Find the following quantities. Number A, equivalent resistance of the parallel combination. Number B, the current flowing through each of the resistance. On number C, potential difference across each of the resistance. Same question, just like example 1, but the combination of the resistors are different. Here, the three resistors are connected in parallel. Parallel means all the left side of the or one end of the resistors are connected one terminal of the battery, or other side of the resistors are connected to the other terminal of the battery. That means all three resistors get full voltage of the battery, that is 9 volt. This is one of the characteristics of the parallel combination. First, find the equivalent resistance of a parallel combination. First, extract the data from the figure. Resistances are given in kilo ohm. You see, the previous example, resistances are given in ohm, but here resistances are given in kilo ohm. R1 is equal to 10 kilo ohm. So convert it into ohm, because the ohm is the SI unit of the resistance. So 10 multiplied by 1000, it becomes 10,000 ohm. 2 kilo ohm, 2 multiplied by 1000 is equals to 2000 ohm, or 1 kilo ohm means 1 multiplied by 1000 is equals to 1000 ohm, and voltage of the battery is 9 volt. Now first find out the total resistance or effective resistance by using this formula. 1 upon Re is equals to 1 upon R1 plus 1 upon R2 plus 1 upon R3. This is the formula to find the effective resistance when the resistors are connected in parallel. 1 upon 10 plus 1 upon 2 plus 1 upon 1. I am using kilo ohm because it is easy to take the LCM in kilo ohm. After getting the answer, we will convert it into ohm. Okay. So 10 is the LCM, and then 10 ones are 10 or 1, 5 2 fives are 10, 5 ones are 5, 1 tens are 10, 10 ones are 10, right? Add this 15 and 16 upon 10. This is the value of 1 upon Re. Cross multiply in this equation, or write the reciprocal of the equation. 1 upon Re means Re. 16 upon 10 means 10 upon 16. So after dividing, we will get the answer 0.625 kilo ohm. Keep in your mind, we have put the value in kilo ohm. Now 0.625 kilo ohm, multiply it by 1000, answer becomes 625 ohm. You see, 625 ohm. Now second part is to find the current in parallel combination. We have learned that current in parallel combination is different in each resistor, but the amount of the total current is equals to the amount of the current of the battery. So I1 plus I2 plus I3 is equals to I. So first you have to find I1. I1 is equals to V upon R1. The value of V is 9 upon 1000 divided 0.009 ampere. Then I2, same method, V upon R2, 9 upon 2000, 0.0045 ampere. Here we are using ohm, not kilo ohm, because the SI unit of current is ampere. So we are using SI unit of resistance also. Alright. Now I3 is equals to V upon R3, and it is 9 upon 1000, and it is 0.009 ampere. In third part of the question, find out the potential difference across each resistor. If you remember, the potential difference across each resistor is same as the voltage of the battery. So not necessary to find the potential difference by calculation. Just write the reason. Since Voltage of the battery is 9 volt. Therefore, we know that V1 is equals to V2 is equals to V3 and is equals to 9 volt. Don't do any other calculation because the voltage of the battery is equals to all the potential differences across the resistor. Okay. I hope you can understand these two examples very well. Example number 3. In this example, you see there are combination of two circuits. One is parallel and this parallel combination connect with this resistor in series. All right. This resistor is connected in series with these two parallel uh, circuits, parallel resistors. In this type of combination of circuits, you have to first find out the resistance in parallel and then combine it with the resistance in the parallel with this in series. Figure shows resistors wired in a combination of series and parallel. Find the equivalent resistance of the circuit or what is the potential drop across resistor R1. You have to find the potential difference of this resistor and find the current I2, current of this resistor. All right, this resistor, current of this resistor through resistor R2. That means you have to find first, you have to find the total resistance of whole circuit, and in B part you have to find the voltage or potential drop across R1, and then you have to find the current across the or through the R2. Okay, now let's see how can we do it. First, extract the data. R1 is 1 ohm, R2 is 6 ohm, R3 is 13 ohm given in the diagram. Voltage of the battery is 12 volt and you have to find V1, V3, I1, I2. Okay. Total for finding the total resistance, first use the parallel circuit R2 or R1. This one. First find the total resistance of these two. These two are connected in parallel. So use 6 and 13. Okay. 1 upon R2 plus 1 upon R3, 1 upon 6 plus 1 upon 13. This becomes take the LCM of 13 and 6, it is 78. Then solve mathematically, it becomes 19 upon 78. Cross multiply it or write the reciprocal of it. RE is equal to 78 upon 19. All right. After dividing, we get the answer 4.105 ohm of two resistors, that is R2 and R3. And one resistor is left, that is R1. Okay. So add this answer to this one to find the total resistance. The answer of this is 4.105 plus 1 is equals to 5.105 ohm. The total resistance of whole circuit is 5.105 ohm. B part. The current through R1 is equals to the current supplied by battery. Understand? Because R1 is connected with battery in series. So we know that I1 is equals to I is equals to V upon R. Here R is total resistance or equivalent resistance of the whole circuit and voltage of the battery is 12, 12 upon 5.10 after division 2.35 ampere. So the current passing through the R1 is 2.35 ampere. Now find the voltage or potential difference across R1. We are applying Ohm's law. V1 is equals to I1 R1. I1 is 2.35 ampere. R1 is 1 volt. So total potential difference is 2.35 volt. So 2.35 volt is potential difference across R1. C is to find the current through R2. We must find V2. We know that V2 is equals to V3 is equals to V minus V1 is equals to 12 minus 2.35. The value of V is 12 battery voltage and V1 is 2.35, that is 9.65 volt. By Ohm's law, I2 is equals to V2 upon R2. V2 is 9.65 or R2 is 6. So the current passing through the R2 is 1.61 ampere. Okay, I hope you can understand all three examples very well. Now we will give you a numerical problem for assignment in the next sharing. Thank you, boys and girls.